Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi. Okay, kita sambung lagi berkenaan dengan topik of integrations. So untuk video kali ini kita nak bincang berkenaan dengan topik of definite integrals. Okay, so untuk topik ni saya suka bermula dengan definisi of definite integrals. Let's say that we have f be a continuous on a closed interval AB. Okay, so we have a closed interval of AB. Then the definite integral of f from a to b is given by integral from a to b fx dx. Okay, then we're supposed to have capital of F, which means that the antiderivative, so the capital of F is denoted for antiderivative, which means it is integrated from the function of f. Now we don't have a plus arbitrary constant anymore because we have limits from b to a. So kita akan tulis in bracket fx, capital Fx, and okay, then we have a limit from b to a, and normally this b is greater than a. Okay, normally b is greater than a. Okay, then after we put the limits, then this f must be fb minus with fa. Okay, so this is actually the process of definite integral, and the definite integral is actually can be illustrated in diagram dekat sini, seperti mana we have fx, then we have a limits from a to b. So if you're looking for integral from a to b, so means that actually we are looking for the area under the curve as well. So the concept is sebenarnya kita nak mendapatkan area under the curve. Okay, so suka sedikit saya sentuh berkenaan dengan rules of definite integral. Okay, so the first one is if a is less than b. Okay, if a less than b, then the integral of ba, okay, we have a limit from ba fx dx will be equivalent to a negative of when we interchange the limit from the original function. So now we have ba. Let's say that b is greater than a, then if we interchange ab fx dx, then we have to put negative. So this will be our first rules of definite integral. The second one is if let's say that we have fa exists. Okay, so katakan kita punya fx dan kita gantikan nilai a dan dia adalah exist, then if you put a limit from a to a of fx, we're supposed to get 0. Okay, we're supposed to get 0. And number 3, if f is a continuous on the interval ab, then f is integrable on ab. Okay, alright, so kita tengok contoh yang pertama. Okay, contoh yang pertama kita ada integral of 2 minus x over 3 dx, and we have a limit from 1 to minus 1. Okay, so as usual we're going to integrate of 2, which is a constant, so we're supposed to have 2x, okay, minus with this is x over 3, so 1 over 3 saya keluarkan daripada proses of integral. So now saya integrate x, saya akan dapat x to the power of 2 over 2. Okay, now we have a limits from minus 1 1. Okay, okay, then simplify. So this one I'm supposed to have 2x minus with x squared over 6. Okay, then I have a limit from minus 1 to 1. Okay, then so saya gantikan nilai 1, bermaksud saya akan dapat 2 tolak dengan 1 per 6. Okay, minus with, okay, minus with, now the second one is I have minus 2 minus 1 over 6. Okay, then after that, so saya selesaikan, saya akan dapat 2 minus 1 over 6, and minus 2 minus 1 over 6, I'm supposed to have 4. Okay, so dekat sini saya akan dapat 4. Okay, so example seterusnya, example nombor 2. Okay, sama seperti mana function nombor 1 tadi, but this time we have a limit from minus 1 to 1. Okay, so now So since we have 2 minus x over 3 also, then we are going to have 2x minus with x squared over 6. So now we just have limits from -1 to 1. Then we are going to have -1, then -2 minus 1 over 6 minus with 2 minus 1 over 6. Okay, which is we're supposed to have -4. Okay, -4. So kalau kita tengok dekat sini, so this is actually proof the first rules that kita discuss tadi, di mana when we interchange the limit, okay, when we interchange the limits, the symbols here, the value here should be a negative value. Okay, so yang ini dia dah buktikan kita punya first rule. Okay, so kalau kita tengok dekat sini, kita ada limit 1 daripada negatif 1, kita dapat 4. Then we interchange the limit from -1 to 1. We're supposed to have -4. Okay, then the third one is, okay, the third one is we have 2 minus x over 3 dx. Okay, the same thing, 2x minus x squared over 6. Now we just substitute with the limits, which is 1 1. Okay, then we are going to have 11 over 6 minus with 11 over 6. This will be equals to 0. This is also proving the rules of number 3 here. Sorry, rules of number 2, whereby it says that if fa exists, then the integral of a f x will be equals to 0. Okay, so this example 3, it's proof that the rules of number 2 here. Okay, mana kita ada integral dekat sini nilai 1 1, bila kita masukkan kita akan dapat nilai kosong. Okay, okay, for example 2, we continue with example 2, definite integral. Okay, okay, we have a functions which is 2 minus x to the power of 3 dx. So now we have a limits from 2 to 1. Okay, now let's start with integrations. 2 minus x to the power of 3. So using the rules, we're supposed to have 2 minus with x to the power of 3 plus 1 over 3 plus 1 times with the coefficients of x, which is -1. And we have a limit from 2 to 1. Okay, then by simplify this, we're supposed to have 2 minus x to the power of 4 divided by 4 times with -1, which is -4. Okay, limit from 1 to 2. So remember, a constant also we can exclude from the integral process of this limit. Kita boleh keluarkan dia sebab dia constant. So jadi saya keluarkan negatif 1/4. Yang tinggal hanya 2 tolak x cos 4 with the limit from 2 to 1. Okay, then -1/4. Okay, so saya masukkan nilai limit dia, 2 minus 2 will become 0. Okay, minus with 1, 2 minus 1 will become 1. 1 to the power 4 is 1, then it's become 1. So now -1/4, 0 minus 1 will become -1. Then therefore the final answer will become 1/4. Okay, alright, then the next example, okay, kita ada 1/x plus 1 dx. So this is actually a special case, if you still remember, special case of integrations, whereby kita ada x to the power of 1 and n to the power of -1. Then yang ini definitely kita akan dapat ln absolute x plus 1, okay, divided by coefficients of x, which is 1. Okay, so normally kita tak tulis 1 sebab di sini normally kita tak tulis lah, so saya tulis di sini untuk pastikan yang pelajar masih ingat rules of integrations for special case of when we have x plus 1 to the power of -1. Then we are going to have a limits from 1 to 0. Okay, kita gantikan limit dia, so we have ln, okay, ln absolute 1 plus 1 become 2 minus with ln 0 plus 1, which is 1. Okay, then ln 2, so ln 1 is become 0, therefore the final answer will become ln 2. Okay, Alright, so we move to the example 3. Okay, example 3. So kita ada 1 over 4 minus x to the power of 3 dx. So yang ini kita boleh tukar dia kepada negative index of a limit from minus 1 to 1. We have 4 minus x to the power of minus 3 dx. So the same thing, we are going to use the rules of power of integrations, whereby we are going to have 4 minus x to the power of minus 3 plus 1 become minus 2 divided by minus 2 times coefficients of x, which is minus 1, and we have a limit from minus 1 to 1. So I simplify this as usual. 2 saya keluarkan sebab dia constant. Okay, 1 per 2. Okay, then we have 4 minus with x to the power of minus 2. Saya tukar balik kepada positive index, di mana kita akan ada 1 per 4 tolak x kuasa 2, and we have a limit from minus 1 to 1. Okay, then by compute the value of limits accordingly. So dekat sini kita akan dapat 1 per 2. So 4 minus 1 become 3. So we have 1 over 9. So 1 over 9 minus width. So 4 minus minus will become 5, 25. So we have 1 over 25. Okay, so 1 over 25. Then by calculating this, samakan pembawah dia, you're supposed to have the value of which is 8 over 225. Okay, alright, and then the fourth one. Okay, sama juga dekat sini kita ada 3 minus with 2x to the power of 1 over 3. Okay, 1 over 3. So we have a limit from 0 to minus 3. Then we are going to have 3 integral of 3 minus 2x. Kita akan dapat 3x tolak dengan 2x squared per 2. Okay, dan kita akan ada limit so this is the power, power of 1 over 3. So this one is 3 minus with 2x to the power of 1 over 3 plus 1. Okay, 1 over 3 plus 1 become 4 over 3. Okay, and then over 4 over 3 times with coefficients of x, which is minus 2. Okay, and we have a limits from 0 to minus 3. Then we simplify this. We have 3 minus with 2x to the power of 4 over 3 times with minus 8. Okay, minus 8 over 3, and we have a limit from minus 3, 0. Okay, and remember, so this 8 minus 3 is a constant. Saya boleh keluarkan sama juga. So kita akan dapat minus 3 over 8. Okay, which is times with 3 minus with 2x to the power of 4 over 3, and we have a limit from 0 to minus 3. Okay, then by computing this limit accordingly, so we're supposed to have minus 3 over 8, and kalau kita masukkan kosong, so kita akan dapat 3 kuasa 4 per 3 tolak dengan so 3 times 2 becomes 6. 6 minus 3 become 3, so 9. So we have 9 to the power of 4 over 3. Okay, and by calculating this with calculator, kita akan dapat nilai dia adalah, kalau dalam perpuluhan, kita akan dapat 5.398. Okay, up to 3 decimal points. Okay, so this is for example 4, and we move to example 5. Okay, example 5, kita ada e kuasa x minus 1 times with e to the power of minus x plus 1. So this one, since kita ada 2 factor, kita boleh expand accordingly before kita start finding dia punya integral. So katakan saya expand, so saya akan dapat expansion. Okay, kita expand dulu. Kita akan dapat e kuasa x darab e kuasa negative x. So we have the same base, so power kita boleh tambah. then x minus x will become 0, which is we're going to have 1. Okay, so e to the power of 0, which is 1. Okay, then ex times 1 become plus e to the power of x, and then minus e to the power of minus x. Lastly, we are going to have minus 1 dx. Okay, so this is integral from 0 to pi. Then kita simplify this. Okay, lastly kita akan dapat 0 to pi e to the power of x minus with e to the power of negative x dx. Okay, then we can proceed with integral. Kita akan dapat e kuasa x tolakkan dengan e kuasa negative x bahagi dengan minus 1. Okay, we have a limit from 0 to pi. And lastly, kita akan dapat this one become plus. Okay, plus e to the power of negative x from 0 to pi. Then kita substitutekan nilai pi accordingly, limits from pi and 0. So kita akan dapat okay, e to the power of pi, okay, plus with e to the power of negative pi, so which is 1 over e to the power of pi, minus with e to the power of 0, which is 1, plus with 1 as well. Okay, then this is actually 2. Okay, then kita akan dapat e to the power of pi plus 1 over e to the power of pi minus with 2. By computing into dengan menggunakan calculator, kita akan dapat nilai dia dalam okay, 21.2. Okay, dengan menggunakan calculator kita akan dapat 21.2. And example yang ke-6, okay, example yang ke-6 ia adalah merupakan substitution. Okay, substitution method di mana kita ada x kuasa 2 bahagi dengan punca kuasa x tambah 2 dx. Okay, so yang ini kita akan gunakan substitution. Of course, kalau dalam case ni previous discussion, kalau kita tengok video sebelum ni, kalau pelajar tengok video sebelum ni, di mana kita akan pilih use substitution kita on denominator, ataupun kita akan pilih yang function yang agak kompleks sebagai use substitutions. So we're going to select u is equals to set x plus 2. Okay, as usual saya akan lakukan proses squaring both side. So saya akan dapat u squared equals to x plus 2. Then saya simplifykan x in terms of u. Then I'm going to differentiate x with respect to u, di mana saya akan dapat 2u. Therefore dx saya boleh tukar kepada 2u times du. Okay, right. So kalau kita tengok dekat sini, we have dx will be going to replace with 2u du. And here we just substitute set x plus 2 with u. Therefore we are going to have integral of x squared, okay, over u, x squared over u. Okay, yang ini kita gantikan dengan u. So dx here kita gantikan dengan times with 2u du. Okay, so I simplify. 2 ni is a constant, saya keluarkan. So saya dapat x squared du. So now we still have x to replace with u. So we are going to use x is equals to u squared minus 2. Therefore saya akan dapat 2 integral of u squared minus 2 squared du. Okay, so now remember this is actually definite integral. We have a limit from 1 to minus 1. Okay, then since we have a limit, then we have to for substitution kita nak kena tukar limit dia. Okay, so now we need to change the value of limit. Okay, so for x is equals to 1, so we're going to substitute into this formula. Okay, so kita akan substitute dalam formula yang formula yang asal ni ya. Okay, di mana kita akan gantikan nilai x tadi dalam formula dalam substitute ni, set x plus 2. So 1 tambah 2 jadi 3. So kita akan dapat set 3 untuk u. And then for x is equals to minus 1. Okay, minus 1 plus 2 which is 1. Therefore kita akan dapat u is equals to 1. Then our new limit for this, in this case, is we have a set 3 to 1. Okay, set 3 to 1. Okay, so kita ada limit yang baru, iaitu set 3 to 1. So this is actually kita tukar limit tadi dengan menggunakan equation yang ni tadi. Okay, u sama dengan set x plus 2. And then we can proceed with integral. So kita ada u squared minus 2 squared du. Okay, so saya boleh expand actually yang ini. Saya boleh kembangkan. Okay, saya kembangkan dulu. So saya akan dapat sini saya akan dapat u kuasa 4 tolak 4u squared tambah 4 du. Okay, therefore kita akan dapat 2 integral of u to the power of 5 over 5 minus with 4 times with u to the power of 3 over 3 plus with 4u. Then we have a limit from 1 to set 3. Okay, then by compute the value of set 3 and 1 accordingly. Okay, so saya masukkan nilai dia. So kita akan dapat set 3. So kita akan dapat 3 to the power of 5 over 2 over 5 minus with 4 times with 3 to the power of 3 over 2 over 3 plus with 4 set 3. Okay, minus with now 1 we have 1 over 5 minus with 4 times with 1 over 3 plus with 4. Okay, so this dengan menggunakan calculator again. So kita pakai calculator, kita kira. So kita akan dapat nilai dia lebih kurang 0.502 up to 3 decimal points. Okay, so this will be a final answer for a function or integral of the function which involve with substitutions, and this is actually a definite integral. Okay, so for a definite integral, yang paling penting dekat sini adalah pelajar harus tukar limit dia. So don't forget to change the limits. Since kita dah tukar tadi ke x kepada in terms of u, limits pun kita kena tukar juga daripada x in terms of u. Okay.